Okay, so a parametric function, they are two separate functions that depend on the same variable. So you're going to have x with its own function and g with its own function, and they're both going to have the same variable that you plug in. In this case, t is called the parameter. The variable that they both depend on is called the parameter, and t stands for time. So let's look at this first example. We're going to first select values for t over the given interval. This is the given interval, so that's how I'm going to select my t values. I can select numbers between 0 and 3. So that's step 1. Step 2, we're going to find ordered pairs corresponding to each t value. So, for example, if t is 0, I'm going to plug in a 0 here to find x, which would be -1, and a 0 here to find y, which would be -2. So the ordered pair is -1, -2. All right, next, for the t value 1, plug in a 1. 1 minus 1, you get 0. Plug in a 1 here. 1 squared minus 2 is -1. So that's the ordered pair 0, -1. Go ahead and find the rest. And then once I find my ordered pairs, we're going to plot the points. Okay. So we found the ordered pairs, that's step 2. We plotted the points, that's step 3. I connected the points, that's step 4. Now I'm going to draw arrows to show the direction. This is also called the orientation. So along the curve as time increases. So as the t values increase, it's going in this direction. So draw little arrows on your line. That's the way that it's going. As your t values increase, that's the direction that it's going in. Here's your next example. You have two equations. That's going to give you a line. So follow the same steps 1 through 5. This should be a 6, shouldn't it? 5, 6. All right, so connect your points to form a smooth curve, and the direction that it was going in, it went this way. As you plotted points, we moved this direction. All right, so guys, that is how you graph when I'm giving parametric equations. Remember, the definition, parametric equations, it's two separate functions that depend on the same variable. Now, I can also eliminate the parameter. So if I eliminate the parameter, that means I'm getting rid of t. So in order to eliminate the parameter, the first step, I'm going to solve for t, and you need to pick one of the equations. So I think the easiest one to pick is this one. So I'm going to go ahead and solve for t. So I have x equals t minus 1, add 1 to both sides, so I get t is equal to x plus 1. That's the first step. Second step is you're going to substitute into the other equation. So I'm going to substitute what I just found into the other equation. So I have y equals t squared minus 2. But instead of writing the letter t or variable t, I'm going to put this in, x plus 1. So this is my equation. This is called eliminating the parameter. We no longer have t's, we have x's. So guys, my new equation, this is a quadratic, so I know it's going to look something like this. That means your domain is all real numbers. I can tell off of my knowledge of transformations that this went left 1 and down 2. So left 1, down 2, that's my vertex. I know it's going to face up. You can get more specific points. You can use the quadratic formula. Well, if you were to multiply this out, you'd get x squared plus 2x minus 1. And if you plug in zeros, your y-intercept is 0, 1. And if you use quadratic formula, you'll get your x values to be -5 halves and 1 half. So that would be here and here. So this is what your graph looks like. All right, so your range, the very bottom is at -2. So that's -2 to infinity. And you have a minimum, you don't have a maximum. Your minimum is at -1, -2. Let's talk about where it increases and decreases. So it increases from here to here. That is -1 to infinity. And it decreases from this side to here. So that's -infinity to -1. Just going to finish this. All right, so we squared both sides. So we get t is equal to x squared. We substitute that into here. And then I'm going to graph it. So I know my vertex is 0, -1 right here. And it's going to look something like that. My domain is all real numbers. Oh, hold on, wait. My domain is not all real numbers. What did we say, guys? Why am I only getting the positive side? Yep, because if we look at the original problem over here, you cannot put negative numbers under here, okay? Because that would give you an imaginary. So that means your t values need to be greater than or equal to 0, which means your x values are also greater than or equal to 0. So that is your domain. You could also write it as 0 to infinity. So you're only going to have the right side of this parabola. All right,